Hello everyone, welcome to Reactify Labs. Today we will learn about MapReduce. MapReduce. Technically, this is one word, MapReduce, okay? So, as the name suggests, it maps something and then reduces something. Hmm. This is a very interesting thing which we all can relate with one example which we may or may not witness daily, but okay, let's talk about it. So, mm, YouTube, Instagram, Twitter, if you have noticed, there is something which all of these platforms show, which is popular something. Okay, maybe popular hashtags, or for Instagram it may be popular reels, or um, YouTube may be popular searches. A hashtag is actually common across all platforms, so it will apply to everything. Twitter also may have popular tweets, something like that, right? So how do they do that? I'm not saying all of these use MapReduce, but I am saying that what these platforms do can be done using MapReduce. How? So on a very high level, it's like, let's say, mm, multiple people use multiple hashtags. Okay, hashtag A, hashtag B, something, 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 something. Okay, so what this MapReduce does is it maps first. Okay, so maps as in it will do this. It will check for the hashtag. Okay, let's say hashtag is A. Okay, then it will take a count. Okay, for example, let's say um, in Asia market. Okay, Asia market has at least 3 billion users, not 3 billion users, 3 billion people. Okay, assuming there are 3 million active users on any platform. Let's take an example of Instagram. Okay, I am just making up the numbers, so don't take it as a source of truth. Okay, so if there are 300 million users, they all are doing something. They are posting some hashtag, something. Let's say someone used A, B, C, something, something. Then what happens is, if you count A, like how many times this hashtag A was posted, so maybe something, maybe 100 times. Okay, but it's not that straightforward. Basically, if there are 300 million users, we all know that this counting cannot be done sequentially, because if we do it sequentially, it will take like forever. So what this MapReduce does is it does this in parallel. Okay, it employs multiple uh, you can say it worker nodes, which would just count for each region. Maybe let's say you need one node to count for entire Japan. Okay, maybe one node to count for entire Singapore. But for India, you may need 10 nodes, and even 10 is a very small number. Just take an example. Okay, so let's say Japan gave that, okay, hashtag A was posted 10 times. In India, each node, let's say for India, um, I may say the I1 node. Okay, for India, the I1 node reported that hashtag A was posted 9 times. I2 node reported that hashtag A was posted 13 times, right? So all the nodes will report their data. Again, not only for A, let's say in Japan, some hashtag C was posted. In India, I1, some B posted, some Z posted, right? So this is mapping. Like, what happens is, this step, this phase, this map phase, it will just allow all the workers, it will ask all the workers to just give it the count. Okay, so now that we have the count for everything, so what it will do now is it will aggregate all these counts. So for example, let's say after all the additions, it may get like this: a is now 1000 times, hashtag b was 500 times, hashtag c was maybe 1500 times. Okay, so this step, like counting the results of all the nodes, this step is called reduce. This phase is called reduce phase. Okay, and I won't write map here, I will write map here so that it doesn't get confusing. Okay, so this is mapping all the nodes getting the count, and this is reducing where all the counts are getting aggregated, and after the counts are there, then you can say that okay, see, this c, hashtag c was the most popular on Instagram in the Asia market. On number 2 it would be hashtag a. Again, hashtag a was second most popular. That's why when you open this maybe Instagram search or maybe Twitter search, you might find that thing that yes, see, these were the popular reel searches or popular hashtag searches. This is what it's done. And again, I am not saying MapReduce does this in those systems. Those systems use MapReduce. I'm not saying that, but MapReduce is one way it can be done by those systems. Okay, it's possible that they may be using this, but I'm not sure. Okay, so I hope this gives you a good understanding, good base point to understand what MapReduce does. Okay, and now that this concept is clear, we can move to the theory part of MapReduce. Okay, just to reiterate, it has only two things: mapping and reducing. So first you map, then reduce. Let's say let's understand it with more simple example. Let's say you have to you are reading a book, maybe Game of Thrones book. The name of that book was Song of Ice and Fire. Maybe you are reading this book and you want to know what was the most popular, what were the 10 most popular words used in this book. 10 most popular words, but you cannot count it, right? Maybe there are 7 books, I'm not sure, but maybe there are 7 books. Okay, you cannot count all the words all alone. So what happened was, maybe you uh, gave this task to your friends. Assume that you have many friends, you have 1 million friends. So what you did was you gave one page of the book, one page of the book to each friend. Okay, and each friend, so there are 7 books, one book may have, let's say, 500 pages, so there are 3500 pages. So you employed basically 3500 worker nodes to give you the count, and each one reported something. Like somebody reported, let's say, Jon Snow. Jon Snow came 10 times, or 10 is too much, 2 times in their page, that page. Another person reported that yes, Jon Snow came 3 times. Another person reported 0. Another person reported 4. Right? Similarly, again, something like this, maybe Targaryen. Somebody reported came 1 times, then 0, then 3, like this, right? So after you have the report from all of your friends, all of these 3500 friends, then you can just add them and get your result, which was the reduce. And what these people were doing was map. So they mapped the count to the words, and then you reduced it, aggregated it to find out which was the most popular word. Okay, so yeah, I gave 2 analogies. One is actual system analogy, and another one something which can be more relatable to some people who may not have noticed those hashtag and popularity features in those apps. So I hope again this now is a good starting point to study MapReduce. Okay, so let's start. We are going to follow the following structure today. First, we will talk about the introduction of MapReduce. Then we will see the components of MapReduce. After that, we will talk about the architecture, then the operations that are performed in MapReduce. After that, advantages, followed by challenges, and ending at use cases. Okay, so let's start with the intro. MapReduce is basically a programming model. MapReduce is a programming model and processing framework. MapReduce is a programming model and processing framework that enables parallel processing of large data sets. As I told you, multiple worker nodes, multiple friends, right? So that's the same thing that enables parallel processing. Actually, sequential processing is not even practical in those distributed systems which have such a huge user base. So this is not practical at all, the sequential processing. That's why parallel processing is by default adopted there. It's a no-brainer basically. So that enables parallel processing of large data sets across a distributed cluster. Across a distributed cluster. Okay. It is designed to handle tasks that involve processing vast amounts of data by dividing them into smaller chunks and processing these chunks concurrently. The model consists of two main phases: the map phase, where data is divided and processed in parallel, and the reduce phase, where processed data is aggregated and reduced to produce the final output. MapReduce is widely used for batch processing and data analysis, and it forms the foundation of Hadoop ecosystem, which provides scalability, fault tolerance, and efficient data management. So you all must have heard about Hadoop. So this MapReduce forms the basis of Hadoop. Okay. Next, let's move to the components. Components. So just a second. Yeah, components start with map phase. Map phase. Then it goes to shuffle and sort. Shuffle and sort. Next is reduce phase. Reduce phase. After that, job tracker and task tracker. Job and task tracker. Okay. So what are these things? First, let's see map phase. So the map phase involves applying a user-defined function to each input record. The function processes the data and emits intermediate key value pairs. The example that I gave you of the counting, that was again a user-defined function. We defined that, okay, we need the counting, right? So again, we can do something else also. Let's say maybe instead of counting, we may get like Boolean, true, false, something like anything can be there, right? The responsibilities of this map phase is first input splitting, which divides the input data into smaller chunks, which are called splits, to be processed in parallel, and a mapping function which executes a map function to process each split and generate intermediate key value pairs. For example, in a word count application, the map function processes text files emitting key value pairs where the key is a word and value is the count. Okay. Next, let's move to shuffle and sort. After the map phase, intermediate key value pairs are shuffled and sorted to group values by key. It transfers intermediate data from map tasks to reduce tasks. It sorts the data by key to ensure that all values for a key are grouped together. As I gave you the example of hashtags A, all will be sorted together so that it can be added. So again, in the word count example, all occurrences of the same word are grouped together to be processed by the reduce phase. Next comes reduce phase. So the reduce phase involves applying a user-defined function to the grouped intermediate key value pairs to produce the final output. The responsibilities includes reducing function which aggregates or processes the group data based on the key to generate the final result, and it writes the final results to the output storage. Okay. And next, job and task tracker. So these are the components that manage the execution of MapReduce jobs across the cluster. Okay. Uh, Job tracker coordinates job scheduling and monitoring, assigning tasks to task trackers and handling failures. And the task tracker executes tasks assigned by the job tracker and reports progress. For example, the job tracker schedules and monitors the execution of MapReduce job, while the task trackers process data splits and reports progress. Okay. Before moving forward, let's change the color and now talk about the architecture. So first step is data input. Next is map function execution. Next is again shuffle and sort, and then reduce function execution. Okay. So what is data input? Data is read from a distributed file system such as Hadoop distributed file system HDFS and split into chunks for processing. Data is divided into manageable splits first, which is processed by a separate map task. Data replication in HDFS ensures reliability and fault tolerance. For example, a large dataset stored in HDFS is divided into 128 MB splits, with each split processed by a different map task. Then map execution function, it's the same thing which we discussed earlier. Each map task processes its assigned split of data, applying the map function to generate intermediate key value pairs. Map tasks run concurrently across different nodes in the cluster. Intermediate key value pairs are stored temporarily and shuffled for the reduce phase. The map function processes the lines of text to emit key value pairs, okay, for each occurrence of word. Then similarly for shuffle and sort, intermediate key value pairs are shuffled and sorted to group values by key, preparing them for preparing them for reduce phase. Then data is transferred from map tasks to reduce tasks, and then key value pairs are sorted. And the reduce function execution, each reduce task processes grouped key value pairs, applying the reduce function to aggregate or summarize the data. First, reducing the tasks uh, aggregate the values for each key to produce the final output, and the final results are written to the distributed file system like HDFS or some other storage system. Okay. Now let's see the operations that are performed in MapReduce. So first is job submission. Next is job execution. Next is monitoring and logging and fault tolerance. So again, it's nothing new. Job submission means users submit MapReduce jobs specifying input data, MapReduce functions and output locations. Then the job tracker schedules and manages the execution of MapReduce jobs. Okay. Then MapReduce provides monitoring and logging capabilities to track job progress and diagnose issues. And fault tolerance, because MapReduce handles task failures by reassigning failed tasks to other nodes and recovering from failures. Because there are multiple nodes, fault tolerance can be achieved easily. Right? Next, we will see the advantages of using MapReduce. So first is scalability. MapReduce can handle large-scale data processing tasks across a distributed cluster, scaling horizontally with additional nodes. Next is fault tolerance. MapReduce provides built-in fault tolerance by replicating data and retrying failed tasks. Next is simplicity. MapReduce simplifies the development of parallel data processing applications with a straightforward programming model. And flexibility. It supports a wide range of data processing tasks, including batch processing, sorting, and aggregation. Now, what are the challenges associated with this? First is performance. Uh, it can be less efficient for certain tasks due to the overhead of shuffling and sorting intermediate data. Next is complexity. Writing efficient MapReduce jobs can be complex, particularly for tasks requiring complex data transformations. Right? Uh, Next is latency. Batch processing model may not be suitable for real-time or low latency applications. And then debugging. Debugging and optimizing MapReduce jobs can be challenging, especially with large datasets and complex workflows. And last, we will talk about the use cases. First is log analysis. Uh, Process and analyze large volumes of log data to extract insights and generate reports is one of the use cases of MapReduce. For example, a web server log analysis job might use MapReduce to aggregate log entries, identify user behavior patterns, and generate usage statistics. Next is data transformation. MapReduce transforms raw data into a structured format for analysis and reporting. For example, a data transformation job might convert raw sensor data into a structured format for further analysis or integration with other systems. Next is index building. MapReduce builds indexes for search and retrieval applications by processing large datasets. For example, a search engine might use MapReduce to build and update indexes for search queries, processing web crawls to create a searchable index. The best example could be Google. If you search something like some uh, something which is common, something which is searched by most number of people appears at the top of your search. So that's MapReduce in action. And next is large scale data processing. So MapReduce processes and analyzes large datasets for various applications such as data mining and scientific research. For example, a scientific research project might use MapReduce to analyze genomic data, performing computations on large scale DNA sequences. MapReduce is very helpful in such kinds of use cases. Okay, so that's all there was about MapReduce. I hope now you have a clear understanding of what MapReduce is and what role does it play in our daily life. So yeah, that's it. Thank you for watching. Please remember to like, share and subscribe. I will see you in the next one.